Today, we are going to discuss a really fascinating concept that mixes biology with mathematics, specifically how creatures evolve over time and how this can be represented using some pretty cool math.
That's right, Alfred. We're exploring evolutionary game theory, and in particular, a concept called the replicator equation, which models how certain behaviors or strategies in a population can change over time.
For example, think of a group of animals where some are aggressive while others are more passive. Over time, if being aggressive gets them more food, we might see more aggressive animals in the next generation.
Now comes the interesting twist. Usually, when studying these systems, the interaction between strategies doesn't change. The rewards and costs associated with being aggressive or passive remain constant.
But what if I told you that the game itself could evolve based on the population's behaviors? This is where feedback evolving games come in, and things get really interesting.
Imagine our group of animals not only compete for food, but also impact their environment, like overgrazing a common area. The more they consume, the less food is available next time, creating a feedback loop. Their actions today affect their environment tomorrow.
And this is where rationality kicks in. Unlike our animal friends here, humans can sometimes make decisions based on maximizing payoffs or rewards. But we're not perfectly rational all the time, right, Alice?
Exactly. We humans can be pretty unpredictable. Sometimes we make the best possible choice, and sometimes we do something completely illogical, perhaps because we lack information or we're just not thinking clearly.
This is where logit learning comes into play. It's a model of learning that incorporates this idea of bounded rationality, meaning we're rational, but only up to a point. And it gives us a way to describe how individuals might learn and adapt their strategies over time.
When researchers studied these feedback-evolving games using logit learning, they found some surprising results. Instead of just heading straight to tragedy with resources being depleted completely.
You're talking about the tragedy of the commons, right, Alice? That's when individuals, acting out of self-interest, end up depleting a shared resource, even though it's not in their long-term best interest.
Correct. The researchers found that depending on the level of rationality in the population, the outcomes could be very different. With low rationality, you get that tragedy, but as rationality increases, you could get sustainable scenarios where the common resource is maintained.
And here's the kicker. If rationality increases even further, high rationality leads right back to a state we're all too familiar with, the tragedy of the commons, where the resource collapses because everyone is acting in their best self-interest.
So in summary, our actions have consequences, not just on each other, but on the environment as well. And the level of rationality in our decisions can lead to a wide range of outcomes, from total resource collapse to sustainable harmony.
It's a delicate balance and shows us the importance of understanding and managing how we make decisions individually and collectively.